All right, with this one, once again, we're going to have to figure out what is the temperature change, and at any point do we go through phase changes. It says in the problem that we start at 106 and then we end at -3. So I know I'm going to start at 106, which is obviously a bigger number than -3, and I'm going to go all the way down to -3. Then what I want to think about is at any point do I go between 100 or 0, because those are phase changes for water. And I do go actually through both. So I'm going to go at 100 here, and then I'm going to go at about 0. You do not need to worry about making it proportional to the actual temperature variations. Okay, so if I look at this, unfortunately, it's going to be crazy because I have 5 different segments, so therefore I'm going to have to do 5 different calculations. The first one that I'm going to deal with is this 106 to 100, where I'm cooling it down. So that would be 106 to 100. So now what I need to know is, because I'm going to be doing a temperature change, I'm going to be using my MCAT formula. It says in it that I have 20 grams, so that's my mass. My C for steam, because right here it's a gas, this is going to be the liquid and this is going to be the solid. My gas C value is 2.00. All I had to do was look at my constants for that one on my constant sheet. Then what I'm going to do is take my final, which is 100, minus my initial, which is 106. And so I get a -6 degrees Celsius. Multiplying that out, I get -240 joules. So within that transfer of cooling, I'm going to lose 240 joules of energy. Now I'm going to deal with this cooling of phase changes. So this phase change in particular is going from a gas to a liquid. And so during a phase change, your formula that you're going to use is Q equals HM. The H in this case is going to be the opposite of vaporization because it's going the other way. So instead of positive 2260, it is going to be negative 2260. And then once again, the mass is the same, which is 20. So multiplying that out, I get negative 45,200 joules. The next stage that I'm going to deal with as far as calculations is the transfer of energy between 100 and 0 degrees Celsius, where I'm cooling my water. So this would be 100 to 0. And for that, because I am undergoing a temperature change, once again, it would be an MCAT formula. Mass in this case is going to be 20 grams. The C for liquid is 4.18 joules grams degrees Celsius. And my temperature is final minus initial, so it's 0 minus 100, which is -100. All right, when you multiply this guy out, you're going to get -8,360 joules. The next one calculation I'm going to worry about is this freezing point, where I'm going from a liquid to a solid. So going from a liquid to a solid, because it is a phase change, there's no temperature change. So therefore my formula is going to be Q equals HM. My H in this case is the opposite of fusion, because fusion is going from a solid to a liquid. So this would be liquid to a solid. So that H value is actually going to be the negative. So it's -334 joules per gram, and I once again still have only 20 grams. Multiplying that out, I get -6,680 joules. All right, and then the final one that I am going to have to deal with is this final cooling stage, which is where I'm going from 0 to -3. So 0 to -3. And because there's a temperature change and it is all the same state of matter, I am going to once again use that MCAT formula. This case, the M is still 20. The C value, though, because it is a solid, is now 2.11. I'm running out of room. And then my temperature change is -3 minus 0, so that would be -3. Sorry, I ran out of room. When we multiply that out, we get -126.6 joules. What I want to do is figure out how much total heat was released by this. So what you're going to have to do, as with other problems, you're going to have to add up all of these guys to figure out how much total energy has lost. And when we add that up, we get -60,606.6 joules. Rounded to 2 sig figs, you are going to get negative, actually because of this guy, you are going to round to 1 sig fig. So you should get -60,000 joules. So I guess this answer should be -60,000 joules, not 61,000. To figure out if it's exo or endothermic, I'm going to look at overall what's happening to the temperature, which is it's going down, which means that it's releasing that energy because temperature is directly related to uh, energy amount. And because the energy amount is going down, I know it is releasing it, so therefore it is exothermic.